Alright, so today we're going to be doing 2.4, which is going to be all about factoring. So the main thing that really you need from this vocabulary page, this is one of those things that it's easier to just see the process instead of like reading how to do the process. But the main thing you need to know is that when you're factoring a quadratic of any form, it needs to be in standard form, decreasing degree order. The next thing you need to know is if you are factoring, in any class that you're factoring, this is for the rest of your mathematical life, okay? You need to take the GCF out before you use any other method of factoring. That should always be step one, if possible, okay? So that's like the important thing to get from this page, and we're gonna now address all the different methods of factoring. All right, so now we're just gonna practice factoring out the greatest common factor. So what number is the biggest number that goes into 12 and 18? Yes.
6.
Very good. So we're going to take out a 6. That's going to leave us with 2k minus 3. And you can always check your work by distributing what you take out back in. So does anyone have any questions about that? All right. Next one is B. So we have a numerical GCF of 8. But in addition to that, we can also take out how many x's? 4 x's and a y. So to refresh your memory, if you were confused by this, you can only take out as many of that variable as the smaller of those have to give. So see how I only have 4 x's in this one, so I can only take a maximum of 4 x's out. So that ultimately leaves me with 5. I have 4 x's left inside, no y, plus 8. And I took out all of its x's and y's. So does anyone have any questions about that? All right. C, what is the biggest number I can take out of those right there? And also in m to the second. So that's going to leave me with 2 m to the fourth minus 5 m minus 1. Yes. Yeah, very good. Yep. So it's m to the fourth because when you are dealing with, essentially what we're doing is dividing by 7m squared. When you divide an exponent by another exponent with a like base, you actually subtract the exponents. So another way to think about it is you actually have 6 m's here, and you took 2 of them out, leaving you with 4. Any other questions here? All right. And the last GCF one we're going to do, no numerical GCF, but we can take out an A and a B, right? Which leaves me with 3B minus 5A plus 8. So look it over. Let me know if you have any questions. I know these are pretty easy, so I feel like you guys probably got these. Does anyone have any questions before we move on from GCF? Okay, does everybody feel pretty confident with their GCF skills? Good? Okay. Now we're going to talk about factor by grouping. This is kind of a spin on the GCF process. So here's how you factor by grouping. You're going to put an imaginary line down the middle. I usually use like a dashed line to indicate that it's not really there. And you split it down the middle. And you're going to factor a GCF out on the left and on the right. So what GCF can you take out on the left here? 8x, right? Which leaves me with 4y plus 5b, right?
Wait, why is it 8x?
Because they both have an x to give. You see it?
Yeah.
Okay, perfect. Now, our goal when we use factor by grouping is to get another something left when you factor that looks the same as this, okay? So with that being said, what do you notice about the signs of both of those terms over here? They're negative. So in order to make something positive, I can do so by factoring out a negative number, right? Because it's going to switch its sign. So when we factor out the GCF, we're actually going to take out a negative version of that, and you're going to see why that benefits us. So what is the GCF of 12 and 15?
3.
3. Also, we can take out an an a, we're going to take out a negative 3a, all right? So negative 3a, and that leaves me with 4y, it's going to become positive, plus 5b, because that's what's left over. So we end up with something like this. Now, what do you notice about the two resulting binomials here? They're the same. That's actually something that you want to happen when you factor by grouping. Because what I'm going to do now is I'm going to erase this little imaginary boundary here. Okay? I'm going to erase that. I got that minus sign here. Now I want you to look at this as one big entity here. Okay, these are like two separate terms. Notice they have this bit in common, the 4y plus 5b. Now we know that if two terms have a factor in common, we can factor it out, right? So here's what you do. You're going to take out whatever they have in common, and then what gets grouped together is whatever was on the outside. And that's your final answer. It's not canceling it out. So here's a way I can show you. Let's pretend that, let's see, a letter that we're not using here. D. Let's say we have D, and we're gonna, if anybody's confused by this, I'm gonna do a little explanation. If you get it, you don't have to pay attention to this right now, but you don't have to write it. So let's say I'm gonna make D equal to 4y plus 5b. So I'm gonna take this and rewrite it as 8xd minus 3ad. See how I was able to do that? Because I replaced this with d. I just took this and replaced it with d. You see what I did there? I rewrote this whole sentence, but I replaced 4y plus 5 with d. You see it? Okay. Now, what could I factor out of this? A d, right? I take the d out, and I'm left with this. Now, what is d actually equal to? I can now substitute in for d with 4y plus 5b, and that leaves me with this. Does that make sense? If that doesn't quite make sense to you, it will, I promise, after time. But what you can always remember, if that confuses you, is whatever's on the outside gets paired together into one binomial. Whatever they have in common, you write once. Okay? Alright, so this one here, we're going to split it down the middle. What can we take out of the left side? 6a, which leaves me with 3 minus, oops, yeah, you're right. I don't know why I'm writing 6. 4y. And over here, we can also take out what? Even bigger, yeah, 16. So here's one thing you have to be careful of when you factor by grouping. When you're normally just factoring a normal equation, you don't have to worry about taking out. When you take out a positive number, you probably just put that number without the positive sign. When you do factor by grouping, you need to put that plus sign out here when you take it out. And not only can we take out a 16, we can also take out a b, right? Which leaves me with 3 minus 4y. So now if we erase our little barrier here, I'm going to factor out what they have in common. Each of the terms have a 3 minus 4y in common. And then I group together whatever is left. But is this fully factored? Who says no? Are you sure? Look at this set of parentheses here. Can't I take out another GCF here? What can I take out? A 2. So I'm actually going to take a 2 out of that. And lastly, does it matter that I rearranged my two binomials? No, because multiplication is what? Commutative. Very good. So it doesn't matter what order I write them in, the answer is still going to be the same as long as it's truly multiplication. Any questions about that? All right. That's it for grouping. Now we're going to get into my favorite type of factoring, which is trinomial. You guys are going to like this one. So, when we're dealing with trinomial factoring, there's a few things you have to check and look for first. Step 1 is you want to make sure that it's in standard form, which means that you have the squared term, the one that's not squared, just the variable, and then the constant, which it is. And then you want to make sure that the coefficient in front of the squared term is 1, which it is. Okay, if it's not 1, you're going to check and see if there's a GCF you can take out, a greatest common factor, always, first. And then you want to check, and if that's not the case, we have another method that we're going to talk about. Sorry, I thought I was going to cough. So, here's step 1. When you have an A term of 1, you're going to look at factors of the C term, negative 48, two numbers that multiply to give you negative 48 that add up to a positive 2. So what's two numbers that multiply to give you negative 48? There's a bunch. Negative 6 and positive 8. And what about negative 8 and positive 6? Would that also work? Okay. There's a bunch more factors you could list. You could say negative 12 and positive 4, negative 4 and positive 12. I mean, you could keep going. But your goal is to get one that adds up to 2. So do we have one yet? We do. Which one is going to work? The top one. Why would the second one not work? It'd be negative 2, but we want a positive 2. So here's how you utilize the answers that you got. You put two binomials, you put your variable in each one, and then you put your two factors that you just got. So it doesn't matter if you do c minus 6 times c plus 8 or c plus 8 times c minus 6 because they are the same thing. Just make sure that the signs are in the right spot. So any questions about factoring a standard trinomial? Yes?
Is there any way to find that quicker and make a negative 6 thing looking forward with a bigger number?
Unfortunately, there's really no way to get quicker at it other than just familiarity by like doing it more frequently. Alright. So letter B, step 1 is it in standard form? Yes. Is the A term 1? So step 2 is after that, check if there's a GCF. Is there a GCF? If there is, you're going to take it out. And now you're going to factor what's in the parentheses as we just did. So you're looking for factors of 36 that add up to 12. Any ideas?
6 and 6.
Good, because 6 times 6 is positive 36, and 6 plus 6 is positive 12. So sometimes you don't have to write them out if it's simple enough that you can do it in your head. Does that make sense to everybody? Okay. All right. So now we're going to look at something like this, letter C. Is it in standard form? Is the A term 1? Is there a GCF? No. No GCF. We cannot take anything out, right? Because there's no common factor. So here's this other method that we use when that happens. So since we can't take out a GCF, and we know we can't factor when the A term is anything but 1, we're going to force the A term to be 1 using something called AC method. Okay? Now AC method only works if you've taken out any necessary GCFs first, which we've already declared there aren't any, so we can proceed. So here's how you do it. You're going to draw an arrow from your A term to your C term. And you're going to rewrite this equation. And instead of writing negative 21, you're going to multiply 6 times negative 21 and put it in that place. So that's going to be negative 126. So I multiplied 6 times negative 21 to get that. Okay? Now you're going to factor it like you just did earlier. Factors of negative 126 that add up to negative 5. So this is where you're going to kind of play around with your calculator. So I see that the number is even. So right off the bat, I see that negative 2 times 63, negative 63 times 2. I'm going to try maybe a 7. Negative 7 and positive 8. 18, negative 18, and positive 7. Now I see that 18 is a factor. What's a factor of 18?
6.
6. Also, what else? 9. I'm going to try dividing by a 9. 126 divided by 9, that gives me negative 9 times 14 and negative 14 times 9. I think we got the one we're looking for, right? Which of those are we going to use?
Negative 9 is 14.
Wait a minute, which one?
Negative 14 is 9.
Good. We need the 14 to be negative. Why?
Negative 5.
Exactly, that one's going to add up to negative 5. So those are the two factors that we're going to pick. Doesn't matter which order you put them in. But we're not done yet, because in order to even factor this, we had to first multiply that a and that c together. So what operation in math do we use to reverse multiplication? Division. Yes. Good outside the box thing. So what we're going to do now, to counteract that multiplication we did earlier, we're going to divide by that original a term that we multiplied by. And what you're going to notice is sometimes it divides in evenly and sometimes it doesn't. So sometimes you just have to reduce whatever these fractions are. So how could I reduce 14 over 6?
12 by 2.
Which would be 7 over 3. And this one over here would reduce to 3 over 2, right? Okay. So now, to get it into a nice factored form, once you've reduced those fractions, if denominators remain, which they do, you're going to take these denominators and put them in front of your variable. What? So the reason that this works is because now, if you were to multiply these back out using like box method or FOIL, you're actually going to get what you started with. Now, just to be transparent with you all, whenever I test or anything on this step is the most common step people forget. They'll multiply, they'll factor, they'll get the factors, but they'll forget to divide by the a. So I just want to put that reminder out there to make sure that if you use this method, you have to fully, commit to using it and make sure you divide by that a value that you multiplied by. So does that make sense so far? Alright, we're going to do another one using this method. Step 1, is it in standard form?
Yes.
Step 2, is there a GCF? Yeah, we can take out a 2, right? So we're going to take out a 2. And we get here. But unfortunately, when we go to take that GCF out, we still have that a term that isn't 1, so we have to use the AC method. The AC method says we can multiply the a by the c, like this. And then that's going to be 8 times 27, which is negative 216. So now we're looking for factors of negative 216 that add up to 30, right? So what about negative 36 times 6? Almost. But what about positive 36 and negative 6? Which of those two do we want to use? The second one, because we want it to add up to a positive 30, not a negative 30. So that's going to be like this. And then, since we multiplied to get here, we have to reverse the multiplication by division, dividing by our whatever we multiplied by, which was 8. In both cases, 8 does not evenly go into either number, which can happen. So we have to reduce each of those fractions. I'm going to reduce this fraction by dividing the top bottom by 4, which gives me 9 over 2. And then over here, I'm going to divide the top and bottom by 2, which gives me 3 over 4. So then from here, what am I going to do with those denominators? Good, bring them in front. Just a second, I'm going to mess this up if I stop in the middle. 2. Do you want your notes?
I got both.
Oh, you got them. Okay, perfect, perfect. All right, so does anyone have any questions about how we factored that? All right, we have one last method we're going to talk about today, and it's probably the easiest one. It's called the difference of perfect squares. So the difference of perfect squares is denoted by subtraction between two perfect square roots. So here's how you factor. You put two parentheses. One has a plus sign, one has a minus sign in the middle. And then you take the square root of the first term and then the second. What is the square root of x squared? What is the square root of 4? 2. Remember yesterday we learned about conjugates? Aren't these actually conjugates of each other? Which means that if I were to multiply them together, the middle terms will do what?
Be the same.
Well, they're going to cancel each other out, right? So that's why there's no x term in here, because they canceled out, okay? All right, next one here, same idea. One's going to be a plus, one's going to be a minus.
Doesn't have a back.
Oh, there you go.
How is the one back?
Probably because that was the one I made copies with or something.
So I picked the one that didn't have a back of the
Correct.
full, like,
You can throw it
300
out.
pages.
So this is going to be the square root of 9x squared, which is 3x. And what is the square root of 25y squared? 5y. And that's it. All right. Now the problem with C is before we use the square root method, we first have to take out an, or a, GCF. Can't we take out a 2 first? So we get here. And now I can use the perfect square method. So the square root of 36 is 6. The square root of r to the 6 is r to the third. So you basically just divide the exponent by 2 when you take the square root of an exponent like that. And then it's just going to be s. And then the last one, once again, I have to take out a GCF first. So that's going to be 2a squared b that I can take out, which leaves me with 1 minus 16a squared. And then this right here is actually the difference of perfect squares, because what is the square root of 1? 1. So this is just going to be 1 here, and then 4a here and here. And the cool thing about this is if you feel like you make a mistake on any of this, you can always check it by just multiplying everything back out. All right, I'm going to hand out your homework. Keys on the board. You have 25 minutes to work.